Here's our first question where we have an absolute value. And the question says, graph the solution to the inequality on the number line, or what I would call the real number line. When I have a question like this, I like to transform the inequality into an equality. So I've got the absolute value of x plus 3 is equal to 4. And my first question to myself is, what values of x satisfy the equality? And looking at this, I can see that if x is equal to 1, then x plus 3 is equal to 4. With absolute values, there's often more than one solution. And when we talk about functions, we're going to see that with some special functions later. But there's also the fact that we could have more than one solution. So looking at this, if x, and I'm just sort of plugging numbers into my mind and guessing, if x is equal to -7, then x plus 3 is also equal to 4, because I have, of course that's absolute value, so I have -7 plus 3. I've got the absolute value of -4 is equal to 4. All right, so there I'm using the absolute value operator. Now let me clear this up a little bit. Now notice that if x is greater than 1, the equation or the inequality fails to hold. And if x is less than -7, it also fails to hold. I should also point out that the way I've written the x's is not entirely correct. X should be greater than or equal to 1, and x should be less than or equal to -7, because if x is actually equal to 1, that this inequality doesn't hold, because it's a less than sign, not a less than or equal to sign. Now looking at the real number line, I could have this, going off to infinity over here and off to negative, oops, not an 8, that's not what I want. I can have 1 here and a -0, sorry, excuse me, a -7 there, and as long as x falls between these two values, the absolute inequality holds. So how am I going to answer this question on ALEKs? Here's the question on ALEKs. I'm going to use the circle that is hollow, and I'm going to identify the 2 points of interest. The 2 points of interest are 1 and -7. Then I'm going to press this line icon, and it looks like it's automatically filled in the correct interval where this inequality is satisfied. And now I will And now I'll press the check, and let's see if we get the right answer. And we did. So you have to remember that it's an open interval or open set, and so we're using the dot that's hollow on both the upper value, and the highest value, and the lowest value. This question is to keep you working on your algebra skills. When it comes to doing this type of question where you have an expression and you're being asked to solve this equation for y2. And what does that mean? They want us to isolate y2 on one side of the equation. Economists, undergrads, majoring in economics, you're going to be asked to do this all the time. If you can do it well, if you can do it easily, if you practice it so that you can do it before the test, you're going to have a great undergraduate career. You're going to be very relaxed, and everything is going to be easy. So let's go ahead and let's try and solve this equation for y2. The first thing I want to do is I want to get rid of this denominator. And how am I going to do that? I'm going to multiply both sides of the equation by x2 minus x1. And so I'm going to have m times x2 minus x1 is equal to y2 minus y1. And I'm pretty much there. I'm going to add y1 to both sides of the equation. And there's my answer. Now let's go ahead and put it into ALEKs and see if it's correct. So I'm here on ALEKs. You can see the question is the exact same question we solved on the slides. So let's go ahead and input the answer that we came up with. Got y2 is equal to m x, and I'll use this button here. And then I press the right arrow to move over x, and I'll press that button again, 1, and then the right arrow on my keyboard to get it to go like that. And the last bit is to add y1. And let's see if we have the right answer. And we do. We have the right answer. So pretty straightforward. Just showing you that really you can multiply both sides of the equation by more than one term, right? We multiply both sides of the equation by x2 minus x1. As long as we do that properly, there's no problems with doing that. I'd like you to take a look at the question in front of you. It says at the top, for each equation, choose the statement that describes its solution. If applicable, give the solution. Now you can see that you've got 3 different boxes to choose from. One is that there's no solution. The second box says, well, maybe the unknown variable has a value. That's the solution, something like w is equal to 2. And the next option is that all real numbers are solutions. So let's go back to the slides now, and let's talk about the possible answers to a question like this. So looking at your slides, I'll let you sort of read it yourself, but you can see that when we solve equation like we were given on ALEKs, there are really 3 possibilities that are going to come up. The first possibility is that we're going to get a contradiction. We're going to get something like 0 is equal to 4 or 3 is equal to negative 2, something like that. If we end up with that result, that means there is no solution. There's no actual solution to that equation. 2 is the most common one. That's the one that you're used to and you expect, is that the answer is going to be something like x is equal to 2 and x is equal to 8 or something like that, and you've seen lots of questions like that. The final possibility is that you're going to get an identity. Something like 0 is equal to 0 or 3 is equal to 3. What that means is that any value for the unknown variable, so suppose the unknown variable is x, so any value of x will satisfy that equation. The value of x does not matter, and any value of x will solve the equation. Right? And that's what it says here. All real numbers are solutions. Now, here's the problem that we're given. So the first thing I'm going to do, I'm going to start with the equation on the left, and I'm going to solve for w, and I'm going to see what I get. So let's multiply 4 inside the bracket. So I've got 4w minus 4 minus 1 is equal to 4w minus 6. Now notice if I subtract 4w off both sides of the equation, they're just going to cancel each other out, or more specifically, they're going to sum to 0. Now I've got minus 5 is equal to minus 6. Well, I know that can't be true, so unless I've made a mistake, this is a contradiction. And there is no solution. Now let's take a look at the equation on the right-hand side. I'm going to start with the same process. I've got 4x plus 4 plus x is equal to 3x minus 6 plus 2. So I'm working out the bracket. Now I'm going to collect like terms, and I've got 5x plus 4 is equal to 3x minus 4. And if I subtract 4 off both sides of the equation, and I subtract 3x off both sides of the equation, I get 2x is equal to minus 8, and x is equal to negative 4. And so you can see that there is a unique solution. There is one solution to the equation on the right. The equation on the left, there is no solution. Our last question is short and to the point. We're going to look at an absolute value equation. This time, similar to the one we just did, there could be more than one solution. There could be one solution, or there could be no solution at all. So to solve this, I'm going to isolate the absolute value of u. And I can do that by dividing both sides by 2. Am I done? Is there a solution? Well, one thing to remember is that absolute value denotes distance on the real number line. Negative distance is impossible. This means that the absolute value of u, which is equal to negative 2, has no solution. It's not possible for an absolute value to be less than 0. And so there's no solution here. I wanted to illustrate to you an example with absolute value where there is no solution. So the solution is not, there's no u that satisfies an answer of negative 2.